my tutorial on strong links and weak links. As an aspiring Sudoku solver, this is probably one of the most important concepts for you to grasp and fully understand. That's why I'm going to explain it first before we dig into the actual solving techniques. There are some special terms that I use for all the different types of links and their various incarnations and applications that you won't find in other tutorials or on other websites. But I think these slightly modified terms will help give you a deeper understanding of how the links work than you would otherwise have by learning the standard terms for the same things. My terms are a bit more descriptive than the standard ones, and I think they make sense, even though they may seem a bit strange at first. So please just humor me for now, and I'll be surprised if you don't agree with me later. Right now, I want to give you a quick overview of these terms and their definitions before we start looking at specific examples. And this is so important that I have written it out for you. So let's read it together. All the links we will discuss in today's lesson will be links in the conventional sense, meaning between two same-digit candidates within a house or between two different digit candidates within a cell. However, when we begin talking about loops and chains in later lessons, there will be a slightly different set of rules. The formal definitions of strong links and weak links will still apply. But within loops and chains, both types of links acquire some additional and surprising characteristics. When this happens, we will differentiate these links in these other roles by using special names for them. So for educational purposes and to learn these concepts in a step-by-step manner, we will first talk about strong and weak links only in the conventional sense as described above. All right, now let's read some important definitions that will be pertinent to today's lesson. A conventional strong link exists, 1, between the only two remaining instances of a particular candidate within a house, and 2, between the two remaining candidates in a by-value cell. And a conventional weak link exists, 1, between any two same-digit candidates within a house when there are 3 or more instances of that particular candidate in that house, and 2, between any two different digit candidates within a cell when there are 3 or more candidates in that cell. There are a few more of my modified terms that we will learn later, but these are all you need to know right now. And don't worry, if all this stuff seems a little cryptic to you at first sight, I will do my best to explain everything in the course of this video and in the adjunct video number 3A. Okay, let's go over to the puzzle board and I'll show you how it all works. Okay, we know that when the puzzle is solved, each of the digits from 1 through 9 can only appear once in any particular house, i.e. a row, a column, or a 3x3 block. So if we see that a digit, say for instance the digit 7, appears as a candidate exactly twice in one house, we know that one of them must be true and the other must be false. Now let's take a look here. In row 1, we see that there are only 2 instances of candidate 7, here in column 1 and here in column 8. So since there has to be a 7 placed in row 1, and there are only 2 possibilities for that 7 to go either here or here, one of them must be true and the other must be false. We don't know which, but one must be true and the other must be false. So when this is the case, we say that there is a strong link between these two candidates. Let's call the candidate 7 on the left A, and the candidate 7 on the right B. So now we can make this statement. If A is false, then B is true, and vice versa. If B is false, then A is true. It works both ways. This defines a strong link. This is the formal definition. If A is false, then B is true. And this works in all three types of houses: a row, a column, or a block. Let's take a look at some more examples. Now we see in row 4, there are only 2 instances of candidate 6. Here in column 3 and here in column 7. So one of them must be true and the other must be false. There is a strong link between those 2 sixes in that house in row 4. And here in row 7, another house, we see that there are only 2 candidate 8s. One here in column 2 and one here in column 8. So they are strongly linked because there are only 2 instances of candidate 8 in row 7. And here in row 9, we see that there are only 2 instances of candidate 9 here in column 7 and in column 9. So they are strongly linked. They are also locked because they are in block 9 and row 9 simultaneously. Okay, now let's take a look at some columns, which are also houses. In column 4, we see that there are only 2 instances of candidate 4. Here in row 3 and here in row 6. So those 2 4s are strongly linked. And here in column 2, we see that there are only 2 candidate 7s in row 2 and in row 4. So those 2 7s are strongly linked in that house, in that column. And also in column 9, we see that there are only 2 candidate 8s. Here in row 5 and here in row 9. So they are strongly linked. There is a strong link between those 2 candidates. One must be true and the other must be false. Okay, now let's take a look at some blocks, which are also houses. In block 8, we see that there are only 2 instances of candidate 2. Therefore, those 2 2s are strongly linked because there are only 2 of them. One must be true and one must be false. And also here in block 4, we see that there are only 2 instances of candidate 7. As you can see, they are strongly linked because there are only 2 of them. And lastly, in block 9, we see that there are only 2 candidate 8s, and therefore they are strongly linked. One must be true and one must be false. But this also works within a single cell when there are only 2 possible candidates remaining in that cell. 2 possibilities. This type of cell is called a bi-value cell, bi meaning 2. And the 2 candidates inside are therefore strongly linked, i.e. one must be true and the other must be false. The only difference here is that within a cell, as opposed to within a house, if there are only 2 candidates remaining, they will obviously be 2 different digits. In this case, 4 and 5. But they are still strongly linked. Okay, I don't need to color the cells because you can see there are only 2 candidates in each one. It's easy to see. The 5 and the 3 here are strongly linked because that's a bi-value cell and there are only 2 possibilities for that cell. One must be true, the other must be false. If A is false, then B is true. Up here we have a 3 and a 9. They are strongly linked, another bi-value cell. Over here we have a 2 and a 9. There's a strong link between the 2 and the 9 because that cell has to be filled with either a 2 or a 9. There are only 2 possible outcomes for that cell. So we say there is a strong link between those 2 candidates. And down here between the 1 and the 6, the same thing. That cell has to be filled with a 1 or a 6. One must be true and the other must be false. Therefore, there is a strong link between those 2 candidates. Also, A and B, when they happen to be the same digit candidates like these 7s in row 1, are said to be a conjugate pair, simply meaning that one of them must be true and the other must be false. Now don't forget that, a conjugate pair. One must be true and the other must be false. There is a strong link between any two same-digit candidates that are a conjugate pair. Although, as I explained in the terminology video, in a by-value cell, the two candidates are not customarily called a conjugate pair, like this 4 and this 5. Even though they are indeed strongly linked, the term conjugate pair refers to a strong link between two candidates that are the same digit, like these two 7s up here in row 1. But not between two different digits, okay? It's a subtle distinction. And don't forget, any link, weak or strong, is always between just two candidates, between two of the same digit candidates within a house, like this, or between two different digit candidates within a cell, like this. Understood? Okay, good. Okay, now let's say there are 3 or more instances of candidate 7, or any candidate, in a given house. We know that only one of them can be true and all the others will be false. So let's take a look here at row 2, which is a house. There are 5 instances of candidate 7, as you can see. So there has to be a 7 in row 2, placed. So one of these 7s is true and all the others are false. So for any 2 of these candidate 7s, let's look at the outside 2. Let's call them A and B. Like before, the one on the left will be A and the one on the right will be B. So for any 2 of those candidate 7s, when there are 3 or more instances of that candidate in a house, we can make this statement. If A is true, then B is false. So if A is true, then B is false, because all the others are false. But for any 2, if A is true, B is false. But notice that in this case, we cannot say if A is false, then B is true. Because if A is false, we don't know for sure which of the other candidates is true. One of them is true, but we don't know which. So when there are 3 or more 7s, or any other digit, if we look at any 2 of them and assume that one is false, the other one could also be false. They could both be false. But if one of them is true, we know that any of the others must be false. This defines a weak link, and this is the formal definition. If A is true, then B is false. Okay, now let's take a look at a column. In column 2, for instance, we see that there are 1, 2, 3, 4, 5, 6, 7 candidate 3s. That's quite a lot. So we know that between any 2 of them, at best, there can only be a weak link. So between this one and this one is a weak link. Between this one and this one is a weak link. If this one is true, then this one is false. And if this one is true, then that one is false. And if this one is false, then we don't know anything about any of the others. And this is the case for any 2 of these candidate 3s. Between this one and this one is a weak link. And between this one and this one is a weak link. Now let's take a look at a block. Let's look at block 5, where there are all these 5s in here. There are 5 candidate 5s in block 5. That's block 1, 2, 3, 4, 5. Now remember, there was a strong link between this 5 and this 3 within this cell. And there was a strong link between this 5 and this 4 within this cell. But between any of these 5 candidate 5s here in block 5, which is a house, there can only be a weak link at best. So between these 2 5s is a weak link. Between those 2 5s is a weak link. Between those 2 5s is a weak link. Between any 2 of them is a weak link. Because in this house, this block, there are more than 2 instances of this candidate. So between any 2 of them, there is only a weak link. And this applies to rows, columns, and blocks. And this is the case when there are 3 or more instances of any particular digit in a house, and also if there are 3 or more candidates within a single cell. Any 2 of those candidates are also weakly linked. So let's take a look. Like here in this very center cell here, there are 4 candidates, 1, 3, 5, and 9. So between any 2 of them, between the 1 and the 9, is a weak link. If the 1 is true, then the 9 is false. Or, if 5 is true, then 3 is false. There's a weak link between the 5 and the 3. There's a weak link between the 3 and the 9. Any cell that has more than 2 digits, in other words, 3 or more candidates rather, there is a weak link between any 2 of them. So over here, there is a weak link between that 7 and that 2. Or over here, there is a weak link between this 5 and this 3. Because there are 4 candidates in the cell, we know if the 5 is true, the 3 will be false. If the 5 is false, then we don't know anything about the others. Okay, look down here, another example. If the 7 is true, the 9 is false. There's a weak link between those 2 candidates because there are 3 or more, here being 4. Here there are 6 candidates here. So between the 5 and the 3, there's a weak link. Between the 8 and the 2, there's a weak link. Between any 2 of those 6 candidates within that cell, there is a weak link. In a weak link, if A is false, then no conclusion can be drawn about any of the other candidates. Another way to look at a weak link is that the 2 candidates cannot both be true, but they can both be false, okay? So let's review. For a strong link, if A is false, then B is true. And for a weak link, if A is true, then B is false. Now here's the catch. Notice that a strong link is also a weak link. Because for a strong link, not only can we say if A is false, then B is true, we can also say if A is true, then B is false because there are only 2 of them. For instance, in row 1, these 2 7s, if this one is false, that one is true. But because there are only 2, if this one is true, that one is false. So a strong link can act as a weak link if need be. Now, what this means is that when we are forming chains, which we will learn how to do later, a strong link can act as and be used as a weak link. It can be thought of either way. However, a weak link cannot act as or be used as a strong link, okay? And when we use a strong link as a weak link, I will refer to it as a surrogate weak link because it is not really a weak link in the formal sense, but it is only acting as a weak link as it can because it has the properties of both. And when forming chains by alternating strong links and weak links, we can make inferences and deduce certain things that will help us eliminate candidates and help us solve the puzzle. This type of chain is called an alternate inference chain, or AIC, and we will learn how to construct and use these chains in the next video, video number 4. But let's not get too far ahead of ourselves right now. For the moment, all you need to remember is that if there are only 2 instances of a particular digit within a house, there is a strong link between them. And if there are only 2 digits remaining in a single cell, i.e. a bi-value cell, there is a strong link between them too. So let's take a look. Between these 2 7s, because they are the only 2 7s in row 1, there's a strong link between them. And between this 5 and the 3, there's a strong link between them because they are within that cell. There are only 2 possibilities, so there's a strong link between them. And if there are 3 or more instances of a particular digit within a house, there is only a weak link between any 2 of them. And if there are 3 or more candidates within a single cell, there is only a weak link between any 2 of them. Like, for instance, in row 2, since there are 5 candidate 7s, there is only a weak link between, say, that one and that one. Because there are 5, There's only a weak link between any two. And in a cell where there are 3 or more candidates, like over here, where there are 5 candidates, there is only a weak link between the 9 and the 1, and there's only a weak link between the 5 and the 2. And lastly, a strong link can act as a weak link because it has the properties of both. Please remember that when we use a strong link as a weak link, we will make this distinction by calling it a surrogate weak link, okay? Well, that's about it. So let's go outside and finish up. In a nutshell, a conventional link between 2 candidates is made in the following ways. 1, between 2 same-digit candidates within a house, or 2, between 2 different digit candidates within a cell. A strong link occurs when there are only 2 possibilities, and a weak link occurs when there are 3 or more possibilities. The statement, if A is true, then B is false, applies to both weak and strong links. But the statement, if A is false, then B is true, applies only to strong links. And this is what sets it apart from a weak link and makes it a stronger connection. In a conventional strong link, because there are only 2 possibilities, one of the 2 possibilities must be true and the other must be false. And in a conventional weak link, if one is true, then the other has to be false. But don't forget that it is possible for both candidates in a conventional weak link to be false. And a conventional strong link between 2 same-digit candidates within a house is also called a conjugate pair. I hope I've made these very important concepts clear, but if you're still scratching your head, please go back and watch this video one more time. I'm sure that you will eventually understand these principles if you think about them enough. You can do it. I have faith in you. And don't forget to watch video number 3A, parts 1 and 2, for more examples of strong and weak links. Okay, that's it for this lesson. I'll see you in the next video where we will talk about the basics of AICs, or alternate inference chains. Till then, be well and be happy.